Welcome back, guys. If I'm getting a sound, question 9, paper 2, 5054. Let's start. Question 9. A microwave signal from a transmitter on the Earth's surface is sent up to a satellite in orbit and is immediately transmitted back to the Earth. Acha, for example, if this is Earth, this is going to be the satellite. Satellite से क्या भेजा गया है? A pulse of microwave from the satellite is received back at the transmitter after 0.24 seconds. So, यहाँ से माइक्रोवेव गई है एंड यहाँ वापस आई है. ठीक है ना? The speed of microwave is 3.0 into 10 raised to the power of 8 meters per second. Calculate the distance from the transmitter on the earth to the satellite. अच्छा, तो basically they have said कि in 0.24 seconds में एक माइक्रोवेव गई है onto the satellite, right? Satellite के पास एक माइक्रोवेव गई है and it comes back within this period of 0.24 seconds. ठीक है ना? 0.24 सेकंड में एक माइक्रोवेव अर्थ से गई है into a satellite and is what do you call transmitted back. That means कि जो इसका आधा रास्ता होगा it will take 0.12 seconds. 0.12 सेकंड यहां से यहां तक सैटेलाइट तक जाने में लगेंगे, ट्रांसमीटर से सैटेलाइट तक जाने में लगेंगे 0.12 सेकंड्स और सैटेलाइट से वापस आने में भी 0.12 सेकंड्स लगेंगे. सो अगर हम 0.12 सेकंड्स को इस फॉर्मूला में अप्लाई कर दें, स्पीड इज इक्वल टू डिस्टेंस डिवाइडेड बाय टाइम. हमारे पास स्पीड क्या है? 300 मिलियन meters per second into 0.12, which is the time taken for the microwave to be transmitted between the transmitter and the satellite. So that will give us an answer of 36 million, which is 3.6 into 10 raised to the power of 7. Let's check. Yes. आपने बस ये दिमाग में रखना है कि इट इज गोइंग बोथ वेज, वरना तो फॉर्मूला लगाना बहुत आसान है. ही हैज टोल्ड अस के 0.24 सेकंड्स में इसने पूरी जर्नी कंप्लीट कर ली है, यहां से यहां तक किया और यहां से वापस आ गया. तो अगर हमने यहां से यहां तक का डिस्टेंस निकालना है तो वील ओनली टेक हाफ द टाइम. ठीक है ना? अच्छा, B1. The microwave signal is used in a telephone system that produces a sound. Waves are described as longitudinal or transverse. Some waves are also electromagnetic. Place ticks in table in figure 5.1 to show whether microwaves and sound waves are longitudinal or transverse to show whether they are electromagnetic. First of all, जो transverse wave होगी that will also be electromagnetic because all electromagnetic waves are transverse. ठीक है ना? First of all, let's look at microwave. Microwave आपको याद होगा, it comes in the electromagnetic spectrum. Therefore, they are electromagnetic and transverse. All electromagnetic waves are transverse. While on the other hand, sound जो है, we have seen it being used as a longitudinal wave. इससे पिछले वाले में भी हमने देखा था कि sound is a longitudinal wave. So sound is one longitudinal wave. अच्छा जी, अब वो पूछ रहे हैं हमसे a longitudinal wave contains compression. Describe what is meant by a compression. अच्छा, compression क्या होता है? Compression in a longitudinal wave is when the particles in the materials are pushed close together. The particles are pushed close together. That is when a compression is formed. ठीक है ना? And that creates a area of high density. मैं आपको इसकी एक एग्जांपल दिखाता हूँ. In this diagram, identify what the compression is and what the rarefaction is. This is gonna be the compression because it is an area of high density, and this is gonna be the rarefaction because this is gonna be the area of low density. So these are the two, compression and rarefactions, and compression is the area of high pressure, right? And rarefaction is the area of low pressure. Very simple, very easy. So that is gonna be it for this video. I hope you enjoyed. Have a great day. Allah Hafiz.